Welcome, everybody. All right, let's take a look at some integrals. And the way we're going to do this is we're actually first going to look at some derivatives, okay? So first, let's look at the derivative of the inverse sine of x to the n. Okay, so n here can be any number in the world, okay? It can be any integer, so any positive or negative whole number. And if we take this derivative, it's inverse sine, okay? So chain rule, inverse sine is the outermost function. So its derivative is going to be 1 over the square root of 1 minus the thing inside squared, okay? Now, if we square x to the n, we multiply the powers. So in other words, this is going to be x to the 2n, okay? Then, chain rule, don't forget the chain rule, we got to multiply. Whoa, what did I just do there? I have no idea what I just did. But anyway, we have to multiply by the derivative of x to the n. And the derivative of x to the n is going to be n x to the n minus 1. The good old power rule. Okay? And, if we write this thing out, what we're going to have is n x to the n minus 1 over the square root of 1 minus x to the power 2n. Okay. All right. So let's keep that in mind. Okay. Let's write down a couple more of these. Let's write down the derivative of the inverse secant of x to the any power. So inverse secant, it's going to be very similar but not the same. It's going to be 1 over absolute value of whatever's in there, absolute x to the n, square root, and then it's going to be x to the n squared, so once again, x to the 2n, and then minus 1, okay? And then once again, let's not forget, I don't know why I was doing that for, let's not forget to multiply by the derivative of what's inside. So we're going to have n, and then we're going to have x to the power n minus 1. Okay? And if we simplify that, we're going to have n x to the n minus 1 over absolute x to the n square root of x to the 2n minus 1, like that. Okay, all right. Now, just for a moment, because integrals are often written this way, just for a moment, let's take this x to the n out of the absolute value, okay? So, just bear with me here. Let's, like I said, we're going to take the x to the n out of absolute value. And if we do that, what we're going to wind up with is n x to the n minus 1 over, and then we're just going to take it out. So x to the n square root x to the 2n minus 1. Okay, now look here. The power of x here is larger downstairs. Okay, this is n minus 1 and this is n. Okay. And so we can actually use this to our advantage. Let's manipulate a little bit more. Let's use law of exponents. So x to the n minus 1 is the same thing as x to the n multiplied by x to the minus 1. And then in the bottom here we have x to the n square root x to the 2n minus 1. Okay, now look here. X to the n over x to the n goes away. And we're left with n over, this x is to the negative 1, so this x is going to go downstairs. We get x square root of x to the 2n minus 1. And here we go. Okay, this is very important. All right, so let's interpret this now. Okay. So if you see, let's look. Let me scroll over a little bit here. I'm going to scroll. I'm going to keep these in view. So this is my derivative of inverse sine. I'll sort of notate that here. This is inverse sine of x to the n, and then it's the derivative. So I'll sort of put this in brackets and then prime it. There's the derivative there. And then this one is the derivative of inverse secant of x to the n. So I'm priming this, okay? So now let's turn this thing on its head, okay? Let's say for a moment, let's say that n equals 1. Then what we're going to wind up with, and let's go in reverse now, okay? So in other words, let's integrate. Let's say we have the integral, and then I'm just going to plug it in here. So 1 x to the 1 minus 1, 1 minus 1 is 0. So we just wind up with 1 on top over the square root of 1 minus x to the 2 times 1. So that's going to be 1 minus x squared. And of course, we got to have our dx up here. And so now, just by doing this, we can immediately see, just by looking, that this is going to be the inverse sine of x, plus c. Okay. Let's do a couple more of these. Let's jump to n equals 3, and let's see what happens. We're going to have the integral of, and again, I'm plugging directly into here. So it's going to be 3x to the 3 minus 1, which is 2, over the square root of 1 minus x to the 2 times 3. So x to the 6. Okay, now let's talk about this one for a minute, okay? The first thing I want you to notice is that the power on the numerator is way less than the power in the denominator. Okay? So this is how we can sort of easily see if this is going to be an inverse sine or a u sub, where u is the entire thing inside the square root. It's not, okay, so in other words, our options here, if we were to see this integral, would be u equals 1 minus x to the 6. That's one option. The other option is recognizing this is an inverse sine, in which case the thing we're squaring here is x to the 3. Okay? Now, this is obviously the correct one because we're talking about inverse sine right now. But the point of this right now is that you all recognize the difference between when to use u1 versus when to use u2 here, okay? So, so again, if the power upstairs is way less than the power downstairs, and you have this square root in the bottom in this way, where you have a constant minus x to some power, then we're gonna want to do inverse sine approach, okay? Because once again, if I do du2 dx, I'm going to wind up with 3x squared. And that's exactly what is on top here. Okay? So, du2 is 3x squared dx. And so this becomes integral du2 over the square root of 1 minus u2 squared. Okay? And then that'll just be inverse sine of u2 plus c. Okay, and then we back substitute, we get x cubed. Okay, great. So now let's compare that with the following. Okay, so so we have these here. Let's compare this last one with this one. Okay. So let's say we have, let me sort of divide this out. Let's say we have the integral of, and what I'm going to do is I'm actually going to keep downstairs exactly the same. Okay. And now what I'm going to do up here is I'm actually going to do, I'm going to have a large power up here. So let's say we have, I don't know, x to the power 17 dx. Okay? So this should tell us right away that we're not going to do an inverse sine, because again, the inverse sine over here has the exponent on top being a lot less than the exponent on the bottom. Now over here we can clearly see here that the exponent on top is greater. Okay, so in this case what we want to do is u equals the whole thing under the square root. So then du dx is going to be negative 6x to the 5. Okay, well that's still not 17. Okay, so what we got to do is we have to do some algebra. Okay, so you know, from here we can solve for x to the 6. I'm going to add x to the 6 and subtract u from both sides. I'm going to wind up with x to the 6 equals, I'm going to add x to the 6, and then it's going to be 1 minus u. Okay, I added that, subtracted u. X to the 6 is 1 minus u. Okay, now, separately, I don't know why it keeps doing that. Separately, x to the power 17 is exactly the same as x to the 6 times x to the 6, so that's x to the 12, and then times x to the 5. Well, check this out, right? Here is my du factor. That's my du, okay? I do have to divide a little bit, okay? So don't forget about that. But basically, du is some x to the 5th, so that's where the du is. All right. And then we have solved for x to the 6 here in terms of u, okay? So then this x to the 6 is 1 minus u. This is going to be 1 minus u times 1 minus u. And now let's work this out, okay? So du is going to be negative 6 x to the 5th dx. And now in this problem, we're going to have an x to the 5th dx. So I'm going to divide both sides by negative 6. And what I wind up with is negative 1/6 du equals x to the 5th dx. Okay? So here we go. We kind of have our whole strategy here, okay? So let me be as clear as possible. And we'll write this thing down. This is going to be integral, and I'm just going to break this down. I don't know why it keeps doing that. It's really, really, really annoying. Okay. So this is going to be x to the 6, x to the 6, x to the 5, over square root of 1 minus x to the 6 dx. And we've converted everything to u, okay? So we're going to have 1 minus u squared, because it's 1 minus u times 1 minus u. And then x to the 5th dx is going to be negative 1/6 du. Okay, so we have that. And then over, and now, of course, u, like we said, was 1 minus x to the 6th. So this is going to be u to the power 1/2 down here. Okay, so now all we got to do is some algebra, separation, and integration. So here we go, negative 1/6. And now 1 minus u squared, if I square that whole thing, it's going to be 1 minus 2u plus u squared. And once again, I have no idea why it's doing all this crazy stuff. I'm not touching anything. All right. So anyway, there's that. And now my pen's not working. Oh, God. Okay. I don't know what's going on here. Why did it stop working? Darn. So frustrating. Just trying to help my students here, everybody. And it's just not working too well. There we go. Oh my goodness. Anyway, over u to the 1/2. And of course I forgot my integration symbol because of all these technical difficulties. And du. Okay. Yeah, negative 1/6, there's that. Okay, so now some algebra. Negative 1/6. And now we're just going to split this. Okay, so we're going to have 1 over u to the 1/2. That's going to be u to the negative 1/2. And this is u to the 1 over u to the 1/2. So minus 2u to the 1/2. And then 2 minus 1/2, that's 4 halves minus 1/2. That's going to be 3 halves. And of course, I am still integrating. So du. All right. Maybe I can get down to here without something screwing up. Okay. Negative 1/6. And now, okay, now we're just going to apply the power rule. Okay, so this is going to be u to the 1/2 over 1/2, which is going to be 2u to the 1/2. Minus, and then we're going to have u to the 3 halves over 3 halves, which is the same thing as multiplying by 2/3. 2 times 2/3 is 4/3. 4/3 u to the power 3 halves. And then here we're going to divide by 5 halves, which is the same thing as multiplying by 2/5. So 2/5 u to the power 5 halves. There's that, plus c. And then, of course, we are going to back substitute, right? So u is 1 minus x to the 6. So we wind up with negative 1 over 6 to square root 1 minus x to the 6 minus 4/3. And then this is 3 halves, so we can simplify that. That's going to be square, I'm sorry. It's not going to be that. It's going to be minus 4/3. And then we can pull a u out. So it's going to be 1 minus x to the 6 square root 1 minus x to the 6. And then here we can do plus 2/5. This is 5 halves. It's going to 5 halves is, 2 goes into it twice. So we're going to have 1 minus x to the 6 squared, square root 1 minus x to the 6. All right. Good. And so now the only thing that we can really do is we can simplify a little bit. There's a square root in every term, so we can write it like negative square root 1 minus x to the 6 over 6. I'm factoring that from everything, leaving 2 minus 4/3 1 minus x to the 6 plus 2 over 5 1 minus x to the 6 squared. And the very last thing we can do, I just now noticed, is we can pull a 2 out of everything. Okay? So if we pull a 2 out of everything, 2 over 6 is like 1 over 3, so we get negative square root of this over 3. And again, I'm pulling the 2 out. So 2 times 1 is 2. Minus, I'm pulling the 2 out. This is going to be 2/3. 1 minus x to the 6. Ooh. Plus, pulling the 2 out. This is going to be 1/5. 1 minus x to the 6 whole thing squared. Plus c, and don't forget to plus c here just in case. There we go. That's about as simplified as I can make it. Okay. So yeah, so there's that. So basically, if the power upstairs is way larger, then you're going to have to do a u sub plus some algebra. Okay, u sub plus some algebra. Breaking it down like this. In terms of powers of what is on the denominator. Okay, so the denominator has x to the 6. And I'm taking the numerator, and I'm saying, okay, well, 17 is 6 plus 6 plus 5. And I need the 5. The 5 is very important. I need the 5 for the du. Because if u is 1 minus x to the 6, then you're going to need at least x to the 5 for that to work. Okay? And yeah, let's remark on that just a little bit. So again, right over here, integral 3x squared over the square root of 1 minus x to the 6. And if we were to compare that to, let's come down here. And again, we're comparing two integrals. We're going to compare the integral of x to the power 5 over the square root of 1 minus x to the 6 versus the integral oh my god versus the integral of x squared, and don't forget the dx, x squared dx over the square root of 1 minus x to the power 6. Okay? So, these are done differently, just like what we were just talking about, okay? So, the way to think about this, and the way you should always think about these types of problems is, here, if u is 1 minus x to the 6, if u is the entire thing here, then du is going to be something x to the 5, which is exactly what we have here. Meanwhile, over here, if we try the same thing and see what happens. If u equals 1 minus x to the 6, we still need something x to the 5 for that to work. And if you look in the top, we don't have x to the 5. So that should tell you it's not going to be u equals 1 minus x to the 6. It's going to be something else. And that is when your brain should say, okay, it's going to be an inverse sign. Okay, so clearly here u has to be x cubed, because that's what we're squaring. And then look at what happens. Du is 3x squared dx. And x squared dx is in our problem. Okay? So yeah, there's that. Now, let's explore something. This is something I just thought of. Let's see how this goes. And that is, what if we have a higher power in the top? Let's try this really quick. Oops. Oh my god, why is it doing that? Like, every time I touch this thing, it's doing this, and I have no idea why. I think I need to turn off the touch. Let's try that. Hopefully that helps me out. Hopefully I stop going crazy here. Okay, let's take a look at this. Let's see how this goes. So what we're going to do is we're going to keep the bottom the same again. And I'm going to try and construct a problem where the power on the top is higher, but we still have to use inverse sign. So if u is x to the 3, let's try a power of 3, right? So let's do 11. I know 11 is not a power of 3, but you're going to see what I'm saying here in a second. So x to the 11 dx. So yeah, this is really good. This is really good. Here we go. Here we go. This is exactly what I wanted to do. So if we try this approach, oh, ooh, wow, it will work. It will work. Holy crap. Let's take a look at this. du dx equals, once again, negative 6x to the 5. And then x to the 11 is just, x to the 6 multiplied by x to the 5. So wow, that is really, really cool. So we can actually do this without an inverse sign. Wow. Okay, let's look at this. Look, can we do this either way? I think we can do it either way. Let's see if we can do this either way. All right. So here we are. X to the 11 is this, and u is this. Okay, so x to the 6 is going to be 1 minus u, just like before. And if I find du is going to be negative. Okay, I've already got that. Du dx is this, so then I'm going to write below. Du is going to be negative 6x to the 5th dx. And we can divide both sides by negative 6, just like before. And we get negative 1/6 integral of, negative 1/6 integral of, and then x to the 6, let's write it this way, right? It's x to the 6 times x to the 5 dx over the square root of 1 minus x to the 6. Okay, now negative 1/6 integral x to the 6 is 1 minus u. X to the 5th dx is negative 1/6 du. And then we get over, and then this is still going to be u to the 1/2. Okay, there's that setup. Now, the question is could we also have, because we can do this now just like we did before. Could we also do it with inverse sign? If so, this is actually really interesting because it means after a while you have a choice. Let's see if it still works out if we try the inverse sign approach, okay? So, how much space do I have? Do I have any space left? Okay, I've used all that space. Okay, I have space this way, so let me come this way. Let me write the problem down again. So, integral x to the 11 dx over the square root of 1 minus x to the 6. And I'm going to try an inverse sign approach. I feel like something weird's going to happen here. But let's see. Let's see how it goes. Let's let u equal x cubed. So then du is going to be 3x squared dx. And how can we break up x to the 11? So x to the 11, we want to break it up into 3's and 2's. So it's going to be x to the 3, x to the 3, x to the 3, 3, 6, 9, and then x to the 2. And there we go. Okay. So we wind up with the following. We wind up with x squared dx equals 1/3 du. So we should be able to use this. Let's see how it goes. This is going to be integral of, and again, u is x cubed, right? So we get u, because this is u times u times u, and then this is going to be our 1/3 du. Okay, so we're going to wind up with u cubed, 1/3 out here, and then a du, and then over the square root of 1 minus u squared. And there we go. There we go. So this doesn't work. This doesn't work. We don't have a rule for how to integrate this, okay? So we set it up, and it just didn't work out, okay? And so what this means is what we originally said was exactly true, okay? And that is, if the power upstairs is larger than the power downstairs of x, then we're going to have to use a u sub plus some algebra, just like this. Meanwhile, if the power of x is smaller on the top, but we still have a square root of something on the bottom, then we're going to have to use the inverse sign approach. Okay, here the power is smaller, and then in these examples, these other examples here, the power is larger. And again, you know, I tried my hardest to do this problem, x to the 11 over square root x of 1 minus x to the 6. I tried to do this with an inverse sign setup, and you can see what happens when you do. You rewrite the whole thing in terms of u, but then we still wind up with a function that we can't really integrate. Okay? So I hope that this clears up some stuff about inverse sign versus a u sub plus algebra. And the other thing that I wanted to point out here is about the inverse secant. Okay? So what this is telling us here, okay, is that no matter what the power is on an inverse secant type integral, no matter what the power is, okay, we are going to always have a lone x down here. Okay? So again, you know, even if n was 10, if n is 10, then we'll have x to the 20 minus 1 down here. And we'll still have this lone x down here because we'll have, again, if n is 10, we'll have x to the 10 minus 1, we'll have x to the 9 over x to the 10. And that will leave us with a lone x in the bottom. And again, the reason that the lone x is always going to be here is because we're always multiplying by the derivative. We're always doing the chain rule. We're always doing the chain rule, and we're always going to have x to the n minus 1 on top. And that's always going to reduce with your x to the n on the bottom, and that's always going to produce a lone x outside of the radical, no matter what the power is, whenever you're doing an inverse secant of x to the n type integral. Okay? So, brief summary. I know I've said this a lot, but brief summary, right? Brief summary. If you see an integral with a square root in the bottom, you have three choices. It's either going to be four choices. U sub direct, U sub plus algebra, inverse sign, inverse secant. Those are your four choices. Your inverse secant will always have a lone x outside of the square root, and it'll always be x to the something minus 1. X to the something minus 1. If you don't have x to the something minus 1, you need to do some algebra, or you got the wrong one. Okay? For inverse sign. Okay? For inverse sign, the exponent, the highest power of x, is always going to be less on top. Okay? And it will be, let's be specific here, it will be more than 1 less. Okay? So if this were x to the 5th, we could do straight up u sub, which is what we were talking about down here. Okay? This is straight up u sub, because it's 1 less. It's 1 less power. But if it's more than 1 less, then more than likely, you're looking at an inverse sign. Okay? So I hope this clears everything up with regard to these types of integrals. Let me know, everybody.